going to be problem solving using systems of equations. Now, this is one of my favorite topics by far of the year, simply because it's really a good example of real life applications. So there are problems that you're going to see as we go through this section that are like, oh, so-and-so makes so much more money than the other person if they have this many hours together, find the hourly rate or whatever it is. So we're going to have word problems here, but we're going to clearly have two or more equations. Thus, right, a system of equation. If we don't have a system, it's not more than one. So we're going to have at least two equations for these examples. So our let statements might be a little bit interesting here. So let's take a look at the first example. Jim has $17 more than Sam. They have $73 together. How much does each of them have? Now, we solved problems like this already, where we wrote variables in terms of each other. But what I would like to do here, I would like you guys to start with a let statement for two quantities. Okay? How much money does each of them have? So we're going to look for X and we're going to look for Y, or J and S for Jim and Sam. So call it whatever you would like. So let's start with our let statements. Our let statements here.
Let Jim's amount of money equal X and Sam's equal Y.
Okay, that works for me.
Well, I bet because if you're gonna do Sam's money equals Jim, you can add instead of minus because he has more. So
It makes the equation easier for you, yeah. So Tori May thought like a step ahead. She's like, let me set it up this way so that the equation turns out to be easier. But Tori May, if you had done it the other way, still the same answer. Okay, just maybe a more complicated step along the way. So those are our let statements to begin. Let's take the first statement and dissect it. Jim has $17 more than Sam. So if Sam has $30, how much does Jim have? If Sam has 30, everybody, how much does Jim have? 47, right? 30 plus 17. So it's always going to be 17 more. So how do I write that as an equation? 17 more.
S, I use that. So
That's fine.
Y plus 17.
That's fine.
Yeah, Y
You're
plus
good.
17 equals X.
Good. So Sam's money, Y, plus an additional $17 will equal Jim's money. How else could I write this? How else could I write this? And some of you I noticed would write it differently.
Y equals X minus 7.
Yeah, you could also say that the amount of money that Sam has is the amount of money that Jim has minus $17. Either way is fine, obviously. One of these is solving for X and one is solving for Y. But we can't write both of those because those are the exact same expression, right? It's the exact same statement. Over here, if I just move the 17 over, I get the exact same result as what I have on the right side here. So I'm not going to write them both, but just know that we can have both of them. That's the first statement. The second statement tells us that together they have how much money? $73. So if they have $73 together, what does that mean if they have $73 together?
X plus Y equals 73.
X plus Y equals 73. And you'll notice here's our system boxed in. Okay, so what we're doing here is we're taking these problems and we're writing out equations so that we can solve a system of equations. Yeah, Hannah?
wouldn't it just be easier to do one equation?
And that's what I was going to say. So in these kinds of problems, if you have this on like a midterm and you want to solve it with one variable only and one equation, you can, absolutely. But you're going to see as we get further and further into this section that some of these problems are difficult to do with just one variable. Okay, but for a problem like this, you could absolutely do that. Okay? So here, what would you use? What method to solve? What method? Arthur?
Substitute.
Yeah, why?
Because X equals, and so you can just put in, well, there's an X equals, so you can just get rid of X already, so you can just do Y, Y, and then in parentheses, Y plus 17 equals 73.
X plus...
Y.
Wait, slow down. You're sorry. I apologize. Jeez.
It's so different because I use S and
And I used S and J, and I'm trying to keep those in my mind. Yeah. So we have Y plus 17 quantity plus...
plus Y equals 73.
Okay, and Hannah, when you said can you use one equation, this is what you're referring to, right?
Yeah, mine is
Okay.
slightly different.
But you're going to have them... Do you have a minus sign somewhere instead?
I I just used different variables.
Oh,
Basically
with the same numbers, just in variables, good. Okay, so what Hannah said was, can't you just go right into one equation? And you can. You could say, well, there's $17 more for this one. This is the normal value.
There was like Hindu singing. It was like
in like India, it's like praise God. It's so crazy.
They're probably watching. They're watching a film upstairs.
No, but it gets like
Guys, we're in Dubai.
it gradually like got louder.
I didn't even
it was like some
pay much
weird,
attention to
chant.
it.
It was like
Let's subtract 17 from both sides. We're going to get 56. So y should be 28. Okay. Yeah, now if y is 28, we take that number, plug it back in right here, giving us x. Okay, and x is indeed 45. So what does that mean? What statement can I make at the end of this problem? What statement can I make at the end of the problem? I know that in this problem, y is 28 and x is 45. What can I say at the end of the problem? Come on, you should all have your hands up at this point, right? If we got to this point, we should know what to do with these quantities. Francis?
Sam makes $28 and Jim makes $45.
Yeah, exactly. Sam was Y's money, so Sam is $28 and Jim makes $45. You're not done with these problems when you get the variables, so please don't just stop there. So your verbal statement is important at the end. Okay? Sam makes this many dollars. Jim makes this many dollars. That is very important to put that at the end of the problem. Okay, so again, Sam makes $28 and Jim makes, or has rather, $45. Any questions on that one? It's kind of a basic one. It's a bit of a recap of what we've done already. The next one is a lot trickier. And the next one you really want to make sure that you use two variables and two equations for this one. Okay? All right, let's take a look at the next problem. So a passenger jet took 3 hours to fly 1,800 miles in the direction of the jet stream. So already it's like we have some vocab going on here. Then it says the return trip against the jet stream took 4 hours. So 3 hours there, 4 hours back. On the way there, you were with the jet stream. On the way back, you were against the jet stream. What was this jet's speed in still air and the wind speed of the jet stream? What in anybody's name is the jet stream? What is the jet stream? What does that even mean?
is it the wind?
Yeah, it's the wind speed. That's all it is. And that kind of indicates it toward the end. But the jet stream is this current of air that flows around the earth. Okay? So in the water, in the oceans, you know, you have convective currents. And those currents also carry a jet stream in the water. So it's a naturally flowing current based on temperature gradients. So if there's differentials in temperature and pressure, it creates wind. So that's what this is, really. Now, that's not the importance of the question. The importance is to figure out what's actually happening now. So here's how I would act this one out. Okay? Passenger jet took 3 hours to fly 1,800 miles. Let's make believe that from here to the wall is 1,800 miles, and I'm the passenger jet. If I were to fly with the jet stream, see, in the direction of the jet stream, what would that mean? Like, this is my normal flying. Imagine I'm a plane, right? I'm flying, going around the air. This is my normal speed toward whatever country I'm going toward. Now the jet stream comes into play. What is that going to do to me?
It's gonna make you go faster.
Yeah, it's going to help me. It's like somebody's behind me pushing me along, right? That's the analogy I want you to think about. So the jet stream is pushing you along. So it's an assistive force. It's something that's helping you. Okay, it's something that's helping you. Now, when you're going back though, since the jet stream is still coming this way, what's happening now as I'm flying this way?
It's going to go against.
Yeah, it's pushing against me. The jet stream is pushing against me. And we are trying to figure out the speed of the actual jet by itself, as if it were still air, and the wind speed of the jet stream. So let's make those our unknowns. Okay, let's make those our unknowns. So we could say that if we want to, well, give me variables. What variables do you want to use for this problem? Because I use ones, but it doesn't matter. It does not make a difference. T?
T and
T?
No, it's easier when you use like S and J, because then you don't need a little.
T and J.
T for what?
T for Tori.
Oh, I thought it was for the problem.
J for jet stream.
All right, T and you want to do J?
Yeah.
Oh, so we're good.
Now J is confusing here because there's a jet speed and a jet stream speed.
Because
If you're picking your own variables, I would go with,
S and W.
yeah, I would go with either like the W for the wind and J for the jet, or maybe X and Y just to be careful. Okay, but it doesn't really matter. We'll use, in this case, we'll use T and W. Okay, T will be the jet speed, and W will be the wind speed. And if you want to use a different word besides jet, just say airplane. Okay? So that might be easier. So you could say T is the airplane speed and W is the wind speed. All right. Now, what's our formula for distance, rate, and time? Because this is clearly a distance, rate, time problem, right? We've got a distance, we've got some rates we're looking for, and we have a time period for each one. Yeah, D equals RT. That's our formula. So write that down at the top. Keep this in the back of your head.
You have two T's.
Yeah, but now we got to figure out what's happening here. Exactly.
If you have to add
Wow.
something.
All right, so if I'm traveling and I'm a plane and I'm flying at 200 miles an hour, but there's wind behind me, and the wind is pushing me 50 miles an hour, what am I really flying at? 250 miles an hour, because I'm going 200, but the wind's helping me with 50, so altogether it's like 250. It's the sum of the speeds. The sum of the speeds, right? And we are trying to figure out, there are two scenarios here. In the first scenario, how long did it take? It took what?
3 hours.
3 hours in the first scenario. And it was a distance of 1,800 miles. Good. Okay, I heard 180, but 1,800. Yeah.
That's really confusing because now there's two T variables.
That's what I said.
Oh, you're right.
I'm
That's
sorry.
what I said.
That's okay. Guys, relax.
It's gonna be
Okay? No big deal. So, we have J for jet speed and W for wind speed. That's fine. Thank you, Summer, for pointing that out. So we've got those two things so far. The time and the distance for the first leg of the trip. Now, on the first leg of the trip, is the wind helping or hurting me again?
helping.
It's helping. So my rate on the first leg of the trip will be not just the jet speed, but we will do what to that? Add the wind speed to it. Again, the jet speed is a constant. It's some number, the amount that the speed of the airplane can go up to. Traditionally, for airliners, between 400 and 500 miles per hour. Pretty fast, right? That's what J really is, the jet speed. But the wind is helping me along the way. So we add on that W. That's the first scenario. And from that information alone, you can write an equation. From that information alone, you can write an equation. What could that equation say? Liam.
1,800 equals T to the quantity of J plus W.
All right, so J plus W
Yeah,
times the time, right? What is the time in this problem, though?
3.
3 hours, right? So let's put a 3 there. Okay, so again, D equals RT. Distance 1,800 equals the rate, which is the speed of the plane and the wind together, times the time it takes to cross the sea or whatever it is that we're going, 1,800 miles. Now, on the way back, there's only really one major difference. If I go somewhere and then come back, the distance is the same, right? So that's going to remain the same. So I can leave 1,800 for the second equation. What's the major difference here, Hannah?
That T equals 4 now instead of 3.
T is 4. It took 4 hours now, not 3 hours. Why did it take more time on the way back? Physically, why, Natalie?
Because they went against the wind.
Yeah, against the wind or against the jet stream. So it's got to take longer. So what can I do with this parentheses that I'm about to fill in, Francis?
You subtract the wind speed.
Yeah, we subtract it this time. So remember, if you're going against the wind, you subtract it. Going with the wind, you add it. Okay? You add it. Now, take a look at this problem here. It might be useful for you to solve and divide by 3 and divide by 4 and get the J plus W and J minus W by themselves. Okay? And you'll see what I mean when you do that. So I would recommend doing that right away. So divide by the 3 and the 4 actually. Instead of distributing. Don't distribute the 3 and the 4. Just divide by 3 in the first one, divide by 4 in the second one. We end up getting 600 equals J plus W, and 450 equals J minus W. Okay? So again, in both of these scenarios, divide by that number. Why did I do that? Who can now see why I did that? What makes that useful in this problem? Look at your two resulting equations toward the bottom there. And what makes it useful, or why is it useful to divide by these numbers, 3 and 4? What do I end up with down here? What do I end up with down here, Arthur?
Like variables by themselves, you don't need to divide like 4 more variables.
Yeah, the variables by themselves good. What else? There's another piece.
You can like now you can easily add the
Yeah, look at the W's. They're opposite coefficients, aren't they? So you can add straight down. Add straight down those two equations. This is like solving simultaneous with elimination. Okay, so again, this is where we started at the top. We came up with these two equations up here. And then we wrote them like this. So add straight down, please. Go ahead and add straight down. You're going to get 1050 equals what? 2J. Be careful, make sure you put the 2. The W's cancel out. So it turns out that the jet speed, not jet stream, the jet speed, the airliner, the plane, can fly at 525 if I divide by 2, right? Okay, and go ahead, what do you get for the wind speed? If this is 525,
You just plug it back in, you get 75.
okay, so we get 75 for the wind speed. Again, remember that once you get this answer right here, you take that quantity. I would personally plug it in right up here. Okay, this is 525, so 525 plus 75 right here gives you that 600 to check. And the answer makes sense. Remember I said it was around like 500 miles an hour for a plane? So you can use your logic also. And this is miles per hour. I should put those units, miles per hour or both. And the wind can be up to 75 miles an hour. Okay, that's not that incredible of a wind speed when you're at a high altitude over an open area. Okay, that wind speed is completely normal. So remember how you take flights and sometimes you fly one place and you fly back and they're different times? Have you ever wondered that? Here's the reason right here. I remember once when I flew from JFK to England, Heathrow, and it was like, say, it's like,
And it took so much longer going back home.
Yeah,
So much longer.
because of the wind
So
speed. It was like something like 6.5 hours there, but then it was like 8 hours back. Now, obviously there's time differentials and those play a role, but aside from that actual time, it was like almost an hour and a half difference because of the tailwind versus the forewind. And obviously they take different paths. They're very slightly different.
Also, like when I go to California every summer to see my grandparents, and when I go, I forget, when we go there, it's a lot longer than going back or something like that.
Yeah, just because again, of the wind speed as you're going along the trip, it does affect the time of your flight. Well, the jet stream is flowing on a convective current, but it's not one way or the other in different locations. It follows a path, but it's not like east to west only. Okay, it changes as a function of location on the Earth. There's not one answer for it. But I'm sure you guys are in bio this year, right? Actually, that's Earth science, right?
Yeah.
Anybody take Earth science? Did you talk about jet stream and stuff like that? I'm sure there was some sort of a graphical that your teacher gave you, and you followed the little pattern where the line goes in the water and such. All right, let's take a look at example 3. An exam worth 145 points contains 50 questions. Some of the questions are worth 2 points and some are worth 5 points. How many 2-point questions are on the test? How many 5-point questions are on the test? So, what is our let statement? That's the toughest part right away in the beginning. What is our let statement for a question like this? Brianna.
Let the 2-point questions equal X and the 5-point questions equal Y.
Good. And let's say number of, right? I should fix that. Number of, because it says how many are there. And we'll call Y the number of 5-point questions. Okay, so we've got number of 2-point questions and number of 5-point questions going on here. All right, good. How many questions are there total on the exam? There's 50 questions, right? So based on that alone, that should be the easy part for this problem. If there's 50 questions total, what can you tell me right away? If there's 50 questions total, what statement can we make?
50 minus X equals Y.
That's one, yeah, absolutely. That's interesting that you said that way. What else could you just say?
X plus Y.
X plus Y is 50. But yeah, you're solving for one already. That's good, Liam. Liam already solved ahead of time. But to make it easier just to see it, right? We start with this, and then as Liam just said, 50 minus X is equal to Y. So he solved this for the Y variable there. But together, there's 50 questions. So if we were just directly translating, that's how I would write it, and then we can solve for a variable. That's one equation. That's one equation. So we've used this fact that there's 50 questions. So in my mind, I'm crossing it out of the problem, so I don't use it again. And some of you need to start doing this kind of stuff on your tests. Once you use a piece of info, maybe realize, oh, I don't need that anymore, so you don't use it twice in the wrong way. Okay? Arthur, second part.
2x plus 5y equals 145.
Yeah, and explain this to the class, Arthur.
Well, if each x question is worth 2 points, so say there's like 2 questions that are worth 2 points, then there'd be 4 points.
Exactly.
And
2 times 2. Keep going.
and then if there's like 3 questions that are worth 5 points, it'd be 15.
5 times 3. So he sees that if you had, say, 7 questions that are worth 5, you'd multiply 7 times 5, which is where the 5y came from. Okay, so we have 2 equations and 2 unknowns. 2 equations and 2 unknowns. Now, for a problem like this, you can solve it any way you would like. It doesn't matter to me. What's easier for you guys? Because substitution elimination, there's no real difference here. Because there's one step to get substitution, just moving one of these over and plugging in. Or you could simply just multiply everything by what? -2. Yeah, -2 or -5. Either one really works. Okay, so it does not matter in this sense. I'm going to go ahead and use elimination. So I'm going to multiply the upper equation by -2. Okay, and now I'm going to be working with these 2 equations right here. So I took the original equation, I multiplied everything by -2, and now I'm going to go ahead and take a look at those 2 equations that are lumped together there. What do I do? What do I do with these 2 equations? Torme? Yeah, or add straight down, in essence subtracting, yes. 2x and -2x is 0 x's. 5y and a -2y is 3y. 145 and a -100 is 45. Therefore,
I'm actually confused. How do you get from X plus Y equals 52? Oh.
I multiplied everything by -2. So we multiplied this whole equation by -2.
Yeah.
And that gave us the third equation down at the bottom there. Okay? So again, we multiply this upper equation by -2. That's not an x, that's times. Let me just put an asterisk to make it clearer. Okay, multiply the whole thing by -2, giving us that bottom one. What's the answer for y? Worth? 15. So that means there are 15 5-point questions on the test, right? Y was defined as the number of 5-point questions if we go back up and look. So there are 15 of them. It says how many of them, how many of each of them are there on the test pretty much. So if there's 15 of these, Francis, how many there are the other? 35. Because together there are 50. Okay, together there were 50 questions, 15 that are worth 5 points, and 35 of them that are worth 2 points. So again, please make a verbal statement. There are 15 5-point questions. There are 35 2-point questions. Okay? Always at the end of these problems, you have to make some sort of a statement. Your variable answer is useful, but if you don't know what to do with that variable answer, it's not very useful. Okay? So if you just leave x and y there, what does that mean? What does that tell me? Okay, so you have to go back, look at your let statements, and make some sort of a summary at the very end of these problems. Okay? Questions on that one? Any trick up or any like slip ups along the way? Anything that was confusing to you? Okay, let's go on to the next one then. This one's a little bit trickier, and you're going to see obviously why right away. Together, John, Bobby, and Kristen have $70. Together, John and Bobby have $39. While Kristen has 4 more than Bobby. How much does each of them have? Okay? Interesting problem. And you'll see in a moment why it's really intriguing. You'll notice something about the variables here. What can I do with my let statements to begin here? What are my let statements? And please use first initials. It makes it easier on all of us, right? So we'll let J, let B, and let K be our variables. What is J? What is J? The amount of money that John has. So John's money. Okay, they're all money. This is going to be Bobby. And this is going to be Kristen. All right? So those are our statements to start. What's the first equation I can write based on the first sentence of this problem? Based on only the first sentence of this problem. Austin.
J plus B plus K equals 70.
Good. So the first statement says that together they have $70. So add them all up, set it equal to 70. The equations are very easy in this problem, you're going to know this, but the solving is a little more difficult because there's how many variables now?
3.
Yeah, 3 variables. Second, together John and Bobby have 39. Together John and Bobby have 39. So,
J plus B plus C.
okay. J plus B is 39. Yeah.
Doesn't this mean K equals 31?
That's what we're going to get to right away. Yeah. So hold off for 1 sec there, Dave. You're absolutely right. The last part says Kristen has $4 more than Bobby. So Kristen is $4 more than Bobby. Agreed? That last statement is a little bit funky the way it looks compared to the others, but the idea is right. So Kristen has 4 more than Bobby. Now, what David said is the point that you want to look at here. It looks complicated. It looks like we're going to have to do, remember all that elimination stuff we did? But you actually don't because of the second statement. J plus B is 39. Well, this is J plus B right here. So just go like this. Put a 39 in its place. And just solve for K. Take a look here. J and B, John and Bobby have $39. It's a lot of work to do this by hand, and you want to do it by hand initially. But you don't actually have to do all that elimination work. So what did you say it was? Kristen has $31, right?
Oh, never mind, I'm sorry.
That's okay. So Kristen will have $31 as a result. Now, if Kristen has 31 and Bobby has 4 more than that, what does Bobby have?
Wait, doesn't Kristen
So Kristen is 4 more.
has 4 more than Bobby?
So Bobby is
So
4 less.
4 less.
Bobby has
So
27.
25.
25.
No, Bobby has.
Yeah. Kristen is 4 more than Bobby. Absolutely. So what number we're going for Bobby is the question. 27. 27. Be careful, not 35. Again, Kristen has 4 more than Bobby. This would be right here. 27 plus 4 equals 31, the number we had right there. Okay, the last part tells us to find John, which is pretty easy. Use the second equation right here. Okay, if this Bobby is 27 right here, 27 plus 12 gives me 39. Okay, so 3 different parts of this problem that initially look very confusing, but they're actually not that bad. You don't have to use a matrix. You don't have to use solving by hand. You don't have to use any sort of elimination method here if you just simply use substitution. You see how substitution does work in this problem? We are, in essence, substituting 39 in for the quantity J plus B. That's the idea of substitution.
Is the matrix going to be on the test that we have?
Yeah, but we're going to do more examples. Don't worry. We got a lot to do still. We're not done with the matrix stuff. We still have to do a lot, and we'll do a lot more examples. The next one we're going to do using the matrix, actually. So I'll show you this. By the way, these are my brothers' names, Michael, James, and Joey. And I used to make this problem with checkers. Anybody know checkers?
Yeah.
Oh, but see, last year nobody knew checkers. They were like, oh, Shake Shack. So I changed it to Shake Shack. But I always go to checkers. When I grew up out in Long Island, and checkers where you got good fries and chips.
Wait,
No, I mean, not the game. The burger store, Checkers. It's like a fast food burger joint. Really good shakes, like banana shakes and stuff. Yeah. All right. Anyway, so Michael, James, and Joey go to Shake Shack or wherever they go for some burgers, fries, and shakes. On their first purchase, or on their first visit, they purchase 5 burgers, 3 orders of fries, and 3 shakes for a total of $35. A week later, on their second visit, they have 4 burgers, 5 fries, and 4 shakes for $39. And a few days later, they're gaining weight clearly, they get lunch from Shake Shack again. They order 6 burgers, 4 orders of fries, and 3 shakes for $42. What does each item cost? Okay, it looks like a lot. It's not a lot at all. It's not, because you're going to use a matrix to stop it. Okay? So let's just write out our givens, or our let statements rather. What does each item cost? So what should I call a burger?
B.
What should I call fries?
F.
And shakes?
S.
Okay? So cost of burger. Cost of, and I'm going to say fries, and I'm going to put one order. So we know that fries, even though it's plural, it's one order, singular. Okay? And cost of a shake. I'm not going to say cost of a fry. That's weird. Right? Cost of one order of fries, I guess? Whatever. Now, those are our givens. We have 3 scenarios. Clearly, we have 3 variables. This is going to work. Okay? It's going to work. So, David, can you give me the first equation we would get from the word problem that you see at the top?
Okay, so it would be 5b plus 3f plus 3s equals 45.
So again, we have 5 burgers, so 5b. We have 3 orders of fries, 3f. 3 shakes is 3s, for a total of $35. 35. And the next 2 come from that as well. Give me the next one. Who's got the next one for us? Tori May.
4B
4 burgers.
plus 5 fries
5 fries.
plus 4 shakes
And-
equals $39.
It's 39. And the last one, finally, the last one worth?
So 6B plus 4F plus 3S equals 42.
Okay. What I really would like to do is to take one more minute. I know you guys, the bell rang, but today happens to be 8th period. It's the only time we have 8th. Can you just quickly take out your calculators? And we're just going to do it on the matrix. We're not going to solve by hand. Okay?
Plug in 5, 3.
I'll write it on the board.
Wait, how do you do that?
If you have like some mandatory meeting that you need to go and it's... If you have basketball, go ahead. Okay? So then hang out for a minute. Guys, what time does basketball start at?
5 minutes. No,
We have time.
Yeah, you have time.
No, they start.
If you feel like you have somewhere to be and you have to go, you can go. But I'm going to continue just for a moment.
How do you, I just don't know what's going on.
Oh my god.
Okay? If you're good at this, maybe help your neighbor for a moment. If you're not, ask your neighbor. I'll come around. Guys, go through this. I'm going to walk around and see if you can help. We're going to go over whatever you go to the head, you just enter in a matrix. Enter. There are 3 equations and 4 columns. So 3 columns. And then just type in the coefficients that are on the board. When you get to that point, hold up, and I'll do the rest when you do it. Okay, now, second quit. Second quit. Yep, go back to home screen. Okay. Now, home screen, so you see the board. Now, once you've done that, you're going to press second matrix. You're going to go to metric. You're going to go down to RR. Stands for row reduced echelon form. You'll never be able to see it. Now, we're doing the REF of matrix N. So we just go back. So right now we're at this point, right? You want to put matrix N in there. Second matrix. Enter. Close. Enter. That's the cost of whatever X is. That's the cost of Y. That's the cost of Z. In order. So burger would be $4. Fries are $3. Shakes are $2. I'll explain more of this in class next time. So that's the process. Okay, so the number was 42, right? Okay, second quit. Then you guys are going to do then we are going to fix the form. Then you go to matrix again. Matrix N, you enter. Burgers, fries, and shakes. Yeah, do you know that you can like, you know the notes are and noodle and stuff, and you do know that kind of stuff? Okay. Talk to your friends and then, yeah, what's your idea for your mom? Okay, I have definitely frick and 6-3, but I either have college doing or the party meeting. On Moodle, my schedule's on there. So look at my schedule, email me tonight. Have an email address? Yeah, just shoot me an email, let me know. We'll definitely come by at some point so we can discuss.
My sister's not kind of captain, but she lives in North Carolina, so she sends me. And I'm getting it probably by Wednesday, which is when your office hours are.
Yeah, so you
So yeah,
can I come in and Wednesday morning?
Absolutely. Yeah, I like the one you have, but yeah,
It's really good.
it's great, but it's not.
It's not what everyone else says.
Not even that. No, it's not. It's not necessary for this level of math. When you get to like calculus, I can use it
Yeah.
for stuff.
I took geometry last year, so.
And it was very useful for
Yeah, it
geometry.
was, it helped, but I mean, it was kind of unnecessary, but. It was necessary.
What do you do once you input everything?
All right. So once you input everything, is that we're all the same step? You quit to go to the home screen. As if you're clearing it out. Then you go second matrix again. So you go back into the matrix, go over to math, and go down to RREF. So keep going down until you get to it's double R, so not the single R. RREF. So we bulb that, which means row reduced echelon form. And what it'll do is it'll put it in like those zeros and ones you just saw. And then we go second matrix, and we're not going to go to edit anymore because we already edited it. We want to actually use matrix A, so it's on matrix A. So just hit enter now. Now this is going to simplify your matrix for you on its own. And this is the results you get right here. Now what this means really is that if you look at this, this is an equation right here. This is really 1B plus 0 fries plus 0 shakes equals $4.
Oh.
This is saying 0 burgers plus 1 order of fry plus no shakes is $3. No burgers, no fries, but a shake is $2. So therefore burgers are 4, fries are 3, and shakes are 2.
Oh,
Okay.
Matrix,
And I'm
you
gonna-
make things easy.
It makes it real easy. Yeah, I'm
Instead
going
of
to
doing
tomorrow
all
the result of this with the zeros and the ones.
You gotta understand the Matrix now.
I'll put it in the video right now. I'll record it so you guys can see it if you need.
So while I could solve it, this is not a hard problem. Not terribly hard for.
It's not
using a
difficult
matrix.
for me exactly. By hand, it just takes time.
Yeah, I was just thinking, like, really, it didn't look terribly hard, and I see, if I just had time, I could easily do this.
Yeah. So again, this first line means that there's 1 burger, no fries, no shakes, and that equals $4. Therefore, a burger is $4.
That's pretty cool, actually.
Okay. The second one is just 1 fry, and that's going to be $3, and 1 order of, or 1 shake is $2. So shake is $2. Okay. That's it for this one.